I'm Professor Rad, and today we're going to talk about additive identity and additive inverses. Let's get started with a few definitions. So, a number is an identity of an operation if it doesn't change the other value as a result of the operation. So, for example, if I took 7 and I added the identity, I would get 7 back. So 7 plus what number is going to give you 7? 0. So 0 is the additive identity. Because any number plus 0 is going to give you itself. Now, once you have an additive identity, you can also talk about additive inverses. So additive inverses are things that you add together that give you back the identity. In other words, additive inverses are any two numbers that are going to add to give you 0. You can think of them kind of like opposites. So for example, we're going to state the additive inverse of each of these three numbers. So basically, we're just talking about the opposite of each number. So the opposite of -6 is a +6. The opposite of 37 is -37. So we would say the additive inverse of -6 is +6, and the additive inverse of a +37 is a -37. Now 0 is a weird one because if you have like the opposite of 0, you just get 0 back again. So 0 is the only number that is its own additive inverse. Kind of cool, huh? Now, since the additive inverse is basically changing the sign of a number, we're going to use this minus symbol to represent an additive inverse. Just like when you are subtracting and you keep change, right? Subtraction changes the sign of the number that's after it. So we're going to use the subtraction symbol or this minus sign to change the sign of the number that comes after it. So sometimes you might see a number written this way. So that will say the additive inverse of 2. Or this way, we would say the additive inverse of -2. Kind of colloquially, we have a tendency to say like -2 or -2. But let's practice using that vocabulary of additive inverse. The additive inverse of -2 or the additive inverse of +2. That's how we're going to treat that notation. Okay, so let's go ahead and find the additive inverse by using this notation. So for the first few, I'm going to write down what it means, and then I'm just going to write my answer. So here I have the additive inverse of -6. That's what this notation means. So the additive inverse of -6 or the opposite of -6. The opposite of -6 is +6. So the additive inverse of -6 is +6. Now in part B, since we're simplifying the expression, we want to follow our order of operations. So we're going to need to do this addition that's in the parentheses first. So 5 plus 7 is 12. And then I'll bring down this negative sign and the parentheses. So we have the additive inverse of +12. So the additive inverse of +12 is going to be -12. Now, for this next example, this is where thinking of this as additive inverse is going to be very helpful. So I have the additive inverse of the absolute value of -4. The additive inverse of the absolute value of -4. So I'm going to kind of follow along with my words as the order of operations, and then we'll see what that looks like over here. So I want the opposite of the absolute value of -4. So let's look at this piece here, the absolute value of -4. What did absolute value do to a number? So the absolute value is going to take a number and make it positive. So the absolute value of -4 is +4. Bringing this down, we want the additive inverse of +4. So what's the opposite of a +4? Well, it's a -4. So the additive inverse of the absolute value of -4 is -4. This is different from what kind of happened up here. Notice up here we had the two negative symbols and we got a positive answer. And down here we have the two negative symbols and the negative answer. So it does make a difference whether you see parentheses and whether you see absolute value. And you might be wondering, but isn't absolute value supposed to be a positive number? Because yeah, it is. When we figure out this absolute value, we get a positive number. But then we have to bring this additive inverse sign down, and the final answer ends up being a negative. So you want to be very careful when you're simplifying these expressions to kind of follow the correct order of operations. Then for this last one, we have the additive inverse of 0. And we saw that exact question on the previous page where we were finding the additive inverse of 0. And we said that's the same as 0. So if you're solving something and you ever get something that looks like a -0, it means the same thing as just 0. All right, so now we have a few problems for you to try on your own. The first three are like what we did at the beginning, stating the additive inverse. And then the next 6 are simplifying the notation like we did here. In our next video, we're going to be seeing how the additive inverse can combine with exponents to try and make things a little bit, more complicated, because that's what we like to do in math, right? Make it more complicated. So I'm looking forward to seeing you then. And in the meantime, have a great day.